Hello everyone, this is Mr. Kozlowski and welcome to Unit 6. Today I'm going to be discussing lecture Learning Target 1, and today Unit 6 is all about matter. So we're getting more into the chemistry aspects of the year, and we're going to kind of finish out with starting at the basic level today and then finish out the last this unit and the next two with some chemistry going through the end of the year. So please pay attention and let me know if you have any questions during this lecture. Today what we're going to be doing is Learning Target 1. And Learning Target 1 states that you have to read and draw particle diagrams in order to describe state changes. You also can apply the kinetic theory to these states of matter, and you have to do both of those skills quite well in order to understand Learning Target 1. The skills are broken down into three separate stages here. Number one, you got to read and draw those particle diagrams as I discussed for each state change. And there's four state changes: melting, freezing, vaporization, and condensation. Those are the four big ones. There's actually six, and I'm going to discuss the other two here in just a moment. You have to apply kinetic theory to all state changes as well, and that includes the other two which I just discussed, sublimation and deposition. So 6 total state changes or states of matter, and we're going to have different state changes along with that. And within those state changes, from going to one state to the next state, you're going to have to explain if energy is lost or gained during that state change. So those are the skills in order to be successful at Learning Target 1. So the states of matter, there's actually 4 states of matter that we're going to discuss in class. They are solids, liquids, gases, and plasma, which is a state of matter that you may have heard of before, but a lot of students your age don't have a good grasp of understanding, and we'll go over that today in lecture. Before we get to talking about what each state is, there's something you have to understand, and that's called the concept of particle motion. We talked briefly about particle interactions in sound waves. Now what we're going to talk about is how they affect matter. All matter is going to contain some particles. And what a particle is basically a tiny piece of matter that is bounded together somehow, usually bounded chemically, and we'll talk more about chemical bonding later on in the next unit. But understand that when we say particle, we're talking about a small piece of matter at this time and point. With this particle motion, all matter and the particles are moving. So even whatever state of matter it is, those particles are moving no matter what. And some people are confused by that. Even solids are moving. And you just, right now, if you look at a solid, you think, all right, it's a motionless object. Well, it's actually, its particles are moving, but you can't see at that particular level. So understand that matter has particles, those particles are moving. And finally, the phase or state of matter is dependent on how much motion there is. Like I said, if there's a lot of particle motion, it's going to be towards the gaseous states of matter. If there's not a lot of particle motion, it's going to be towards the solid states of matter. So understand that particle motion determines the phase of matter. So let's talk about solids. Solids, like I said, are very, what you would say, motionless, but they aren't. They're just strongly connected to each other, and these particles are arranged in tight repeating patterns. And some people call these like a matrix of solid particles or matrix C, but basically just understand solids packed tight together, very close together. These particles are moving, and they essentially what they do is vibrate, but they do not move very much from their rest position because of their closeness. They're tight packed together. And then finally, the last thing you need to know about solids is that they have a rigid shape. They have a definite shape, and if they change shape, it's most likely they have to break that solid. Sometimes solids can be a little bit squishy, like clay. Other types, they can be very rigid, like a hard table or a desk. So again, we'll look at plenty of examples of what a solid is. Liquids are connected but contain weak connections between them. So understand liquids. They're very close together, but not as close as solids. And their particles can disconnect and reconnect, allowing the particles to slide past one another. So there's more movement of the particles in liquids. And then another unique thing about liquids is that they will take the shape of their container. So understand that liquids don't have a definite shape, and their volume is due to their shape of the container. Finally, gases. Gases are particles that are very far apart and they have more room to move. They're not connected at all, and they're actually moving very, very freely. They're actually moving a lot more and faster than a solid particle would be. So understand this. If you look at this picture, you can see that there's a lot of space in between those particles there. Finally, plasma. Plasma is similar to gases, but the atoms in plasma have lost their electrons, leaving generally a positively charged particle, and this is due to being heated to very, very high temperatures. Plasma, examples of plasma, any star contains plasma, so Earth's sun contains plasma. Flames, so if you see an open flame, that is considered plasma. And then also neon signs, the material in neon signs, that's a plasma type of matter there as well. We're generally going to be talking about the first three that I discussed, and plasmas we kind of explore later on this year. Kinetic theory is basically related to temperature and energy, and we have to apply kinetic theory to these particles and how motion affects temperature and energy. So basically, thermal energy is kinetic energy of particles and matter, and particles always have some sort of kinetic energy, meaning the particles are moving. So basically, this energy will determine the phase of a type of matter that it can be found in. So for example, if we look at solids, liquids, gases, and plasma, solids have the least energy, and if you add energy to it, you get a liquid. Liquids, if you add energy to it, you're going to get a gas, and gas, if you add more energy to gases, you're going to get a plasma. So basically, the state of matter changes as you add more energy. It also, if you subtract energy as well, or energy is released from one of these states of matter, you can convert from a gas to a liquid, or a liquid to a solid, and even a plasma to a gas. So understand temperature and energy basically determine how fast the molecules move, and that movement will determine what phase of matter that material is in. So phase changes of matter. This is determined by kinetic theory. So if we look at liquids versus solids in both of these situations. So a solid to a liquid, we call that melting. And basically this melting is determined by the temperature at which a solid will become a liquid, and this is called melting point. And in this melting, it occurs because energy is added to the solid phase. Liquids to solids, that is equal to freezing. And for the freezing point, that's going to be the temperature at which a liquid will freeze and become a solid. And since we are going from a liquid to a solid, basically energy is released or lost in these particles. So understand energy and kinetic theory play a big role in the phase change as well. Just one last thing about liquids to solids. The melting and freezing points, they are actually the same temperature. So please be aware of that. It just depends what direction or which way the energy is going in that type of matter. Finally, let's talk about liquids to gases. First, if we go to liquid to a gas, you're adding energy to that, and that's called evaporation. And when a liquid starts to boil, this is when evaporation starts to take place. So, and we have the boiling point, that's the temperature at which liquid particles are going to become a gas. If we're going the other way, where energy is released, we're going to a gas to a liquid, this is called condensation. So a condensation point is the temperature at which a gas becomes a liquid. Condensation and boiling point are the same temperatures as well. Examples of condensation, when you wake up and the grass is wet, that's water vapor condensing onto the grass due to temperature change. So that's called condensation. If you ever had a soft drink or a soda bottle that will kind of, they call it sweating, that's actually condensation on the soda bottle. So we'll look at plenty of examples of these phase changes. Finally, the last phase changes, if we have solids to a gas and we skip the liquid part, that's actually called sublimation. Energy is added to this, and this prime example of this is dry ice. So if you ever seen dry ice, you get some dry ice from some hardware store or gas station that sells it, and you put it up into normal air temperature or room temperature. And basically what that is so far above the boiling point of dry ice, you go from a solid to a gas immediately, and that's called sublimation. The opposite way, where energy is released, you're going from a gas to a solid, that's called deposition. And basically examples of this would be like frost crystals on a window. So this happens sometimes in houses where you have maybe it's cold outside, like a winter day like it is in Wisconsin, very cold, and you have so much heat and there's a lot of moisture in the air and a lot of water vapor, and hits the cold surface of the window and immediately goes to a solid, freezes right away. So that would be called deposition. So those are the phase changes. There's 6 of them you have to know, and the more you can apply kinetic theory to those phase changes and explain that, the better off you're going to do in this learning target. So to review, you will have to read and draw particle diagrams. This is going to take some practice, but if you look at the particle diagrams in the PowerPoint, they are right there. It shows you the examples. You will have to be responsible for the shape, speed, spacing, and volume of these diagrams. So please be aware of that, whatever I ask you, if it's a phase change or just a general state of matter. Okay. You will have to define the state changes. So those 6 of them you have to know, and know the definitions and know which way they're going, know if energy is released or not, which is basically applying kinetic theory to determine those proper phase changes. So again, the second 2 and 3 bullet points there kind of relate to each other. And then finally, the last bullet point, explain if the energy is added or released during the state change. So again, this learning target builds upon itself, where, all right, here's the state of matter, explain in terms of particle spacing, particle motion, define the state changes, and then what happens if we're adding or subtracting energy. Okay? So that's pretty much the learning target. All you have to do for this one is take notes. I think you guys are appreciating that much more and getting more out of it. So make sure you take good notes. These videos are getting longer with more content, and I'll check that in class. So let me know if you have any questions. Thanks.